give you a view of my stomach. Thank you, YouTube. I did a short on... Let's get the generator in view and the schematics. So I printed one of them out and colorized to match what the colors of the wires were, so I could trace some of the stuff easier. This is just a trickle charger. Keep this battery charged up. This has a trickle charger, but it's assumed that this will always be plugged into live power on this side. This would be your hots for your split phase, for your 240, and then your neutral would be over here. And when the live dies, then this will feed power into your system, into your loads. Your loads would be over here. So your loads would be hooked up over here. You'd have to make sure you have your earth grounding correct, so you don't have any ground loops. This is your lug for grounding stuff. You can see it's connected to the case. It has quite a few more terminals hooked to it. And then it has all this other stuff going on here, neutrals and grounds hooked together. Oh my. Well, in this case, it's the only generator of power since we're off grid. So let's take a look at it. So we have no live coming in. So right there, that presents a problem because this entire system is meant to auto start when there's no live coming in. That's its trigger. Now, and it doesn't have any kind of like exception for that in this 1972, in this schematic. You definitely say after staring at the schematic for days and colorizing it that this is the schematic for this generator. So on this you had some stupid boomer remove the plate that was here and here, so the identification plates are gone. The only plates we have to go on were this plate from the manufacturer of the motor, and then you could take this cover off quite easily. There's a screw here, there's a screw on the other side. You take the cover off, and then you can look at the numbers on the coils and the windings, and that will tell WINCO support, assuming they're around when you're listening to this, what kind of generator you have. So this is very unusual. Normally you would get a generator like this with two plates here that would tell you quite a bit of information, and then you can go on WINCO's website and download most of it. This is a non-colorized but higher resolution version of that same schematic. And this is the PS5, a 5 kilowatt version of this generator that has a few more bells and whistles and a simplified charging circuit with an adjustable rheostat. So instead of a high-low setting, just right here, and this goofy-ass high-rate charge lamp, this just has a rheostat that you can adjust right there. I don't know what the value of the rheostat is, so I could do a full conversion from this to this design, which is better, but I don't know what the value of that rheostat is. So what they're doing here, in case you want to do this modification yourself, you can figure out what the value of that is, which is a variable resistor. It's adjusting the amount of output from the secondary winding on this transformer. So you've got your AC coming in, either from the generator or from line on here, and then this charging transformer, that's what it's labeled as somewhere, charging transformer, there we go, is outputting I don't know how much, 15, 20 volts, somewhere in there. And you can see on the output, the secondary, it's got an inline resistor to drop the voltage before it goes into a rectifier bridge to create DC. So you've got your positive coming out of the bridge here, and you've got your negative, which is also a ground. So this area here where you see all these wires coming in, you can consider that to be the same thing as this neutral terminal or ground over here, this ground or the ground of the battery. So the way, because it's DC, you know, if this is producing more power than the battery, it's going to send power into the battery. If the DC system on here is dead because this charging transformer is dead, then the power is going to go out of the battery, and eventually your battery is going to die. So if everything is working, you should see this milliamp meter, which is showing you relatively like how much current's going into the battery, how fast you're charging your battery, essentially. This should go up. And so this rheostat, if you look at how it's hooked up to this milliamp meter, you can turn the rheostat to, it's like a variable version of that. So the rheostat, along with this, adjusts the power output of the charging transformer and will adjust the milliamp meter real time, whereas on this older model, just flipping it from trickle rate charge to high rate charge should cause this to jump between two settings. And it looks like it only goes up to 2 amps, so it's not going to, you know, probably sits right in the middle when it's doing a trickle charge, and the high charge is probably 2 amps. I don't know. It's a stupid system. It's overly complicated, and they definitely improved the layout here with basically the same components on this newer model. So on here you have this. This is the colorized. See how they have that high charging indicator lamp, and then they have sort of a default circuit, and then if you flip the switch, both those contacts close. One lights up the lamp, and the other one sends more power to the battery, which in turn should cause the ammeter, which is represented down here as DC ammeter, to show more charging to the battery. So the ammeter isn't for how many amperes you're generating for your loads AC, it's for how much power you're sending into the battery DC. So these are two different things. Yeah, it even says trickle rate charge down here. Maybe if you slip this to high rate charge, I haven't looked at it close enough, but my guess is if you slip this to high rate charge, this light comes on and this ammeter maybe doesn't even register, because high rate charge is going to have to be over 2 amps, and you don't want to peg this meter, so it may effectively take this meter out of the circuit if you flip the high rate charge. What else? There was a switch on here. The stock switch was test and auto. Well, the problem is, since we're off grid, we're not feeding this with 120 volt AC or split phase 240. We're not feeding it with that. So if you are feeding it with that, what happens is when that feed stops, this thing kicks into motion. Well, the only in auto mode, it starts right up. In auto mode, I meant to flip it over to hand crank, but in auto mode, it will run on the original wiring setup. It will run when there is no AC power. On test mode, it will run whether or not there's AC power, because you want to just run the generator. You have AC power, everything's fine, but you want to run the generator. I don't want that, because those two settings would mean that either position would always run the generator, and there would be no way to turn it off. So they added a switch on the side which interrupted power to that and interrupted power to that relay, or it was that, and did something. Anyway, it did it wrong. I took it out. It looked pseudo factory, but it really wasn't. It was a double pole single throw switch, and I took it out because it was wrong. It was just wired wrong. So, and then I just used the schematic to wire everything back to the way it was, to the way it should have been. I still have some loose wires in here I need to tidy up. And you do need to tidy these up, because like this relay, it moves. So you can't have anything in the way of that relay, and that one moves too. So you have to make sure that's clear as well too, and that these wires aren't getting bound up with anything when you're closing this. This is just sort of temporary sloppy right now until I get everything like ironed out, which I feel like I have, so I'll probably end up cleaning it up here pretty soon. So the middle position, so all this is affecting where the ground goes. If you can imagine that this switch is being fed with ground, and then you can send the ground here or there, it has a different effect on the board depending on what you're grounding. If you go like this to stop, it sends ground to coil ground, so the motor won't fire, but it also does something else. I can't remember exactly what, but basically all you have to do is follow the new schematic and see how they're doing things. Here they've got a ground. Remember I told you this was ground over here, and the selector, four-way selector switch, is being used to either send it to check, which will run the motor regardless of whether there's power coming in or not, which again, that's equivalent to the old test mode, and I don't need that. Or it'll set it to auto or stop or hand crank. So you can see what I did. The middle position of that three-way switch is hand crank, not connected. The auto setting is this, and the stop position is that. I know that position, among other things, if you follow this line for stop around to here, it connects to here, but then this also connects to engine magneto, to ground the magneto. So when this is connected to ground, when this is not connected, the engine will run. When this is connected to ground, it'll kill it. The other thing that you're probably going to do is, because it's a mid-70s Briggs, is get yourself one of those solid-state igniter coils and then just bypass the points. Now you can, if you don't want to pull the flywheel, you can cut the wire, the primary wire that goes up to the coil, which acts as a way to get power to the coil, and it also, well, how does it work exactly? It's a point system. It interrupts power to the coil, causing the field to collapse, causing the high voltage spark. The problem is the points get dirty, they get worn out. So you can, if you want to be really sophisticated about it, you can take this nut off with impact. You can pull this with a standard puller kit like Harbor Freight, and then you can disassemble the point assembly and put all the parts back in, cover it up. It won't be in the way of the crankshaft. It'll just be sitting in there. And then you can disconnect the wire that runs from the old coil down to the points as well too. When you're in there, take the old coil off, put the new coil on, because it won't have that primary wire. It will have a tab to ground it out. And that tab's supposed to be hooked to this yellow wire you see I've added because the original was missing. And it comes down to this terminal here, which is isolated from the frame. So this is not electrically connected to here, it's isolated. And then this runs back to this wire, which on the schematic is yellow. You can kind of see some of the yellow bleeding through. And that ends up going up through here, and that's this yellow wire here. So, and that yellow wire ends up over here, and then we've got our grounding wire that runs to our switch. So if we have this in stop or hand crank, it won't start. And in fact, if it is running and we switch it to hand crank, it'll stop it from running. So I'm not really 100% sure about the hand crank position as far as like how electrically that works, or I've made all the proper modifications so that a hand crank, which is winding a cable around here, and giving it a yank, will work. But it's there, and technically it's possible, and this is wired correctly for it. There might be something else in here I need to do. Definitely the stop makes sense to me, and the auto run makes sense. So if I've got it in stop, it's not going to run, even if the battery is hooked up, and so on and so forth. Now what I will be doing in the future is, because the modern all-in-one inverters use a dry contact relay, so when your LFPO batteries, when your off-grid batteries are low, your charge controller, inverter, and everything, you know, the all-in-one system that you have will close a dry contact relay, which, you know, if you have like a 24 volt or 12 volt system, right, it'll send the signal back. So basically you have to have a remote wire on here, and that isn't included in this schematic, but I think I can figure out like how to add a remote wire to this. It may be as simple as interrupting this, you know. But I definitely wanted to have a stop switch at the generator, so while I'm doing all this other stuff, I can start and stop it manually. Later on, I can add that additional thing, and this stop will override like all of that. So maybe it's as easy as just pulling this off and interrupting the circuit flow here. So you have to have it on auto run, but the contactor also has to be closed so you complete this circuit and allow it to run. So, and if this is stopped because it grounds out the igniter, the coil, it's definitely going to stop it, even if that other system is closed. Remember, you got to have it in auto run. It also has to be closed, so you can still stop it over here just by flipping it to stop. So one of the things is, and there's a mixture in here, you've got what looks like primary wire, which is handling, you know, 12 volts like for the coil on here, but the coil on here is like, you know, maybe higher voltage. So you got to be careful. This is definitely a high voltage coil here, 120 volt AC, and they're using primary wire and 12 volt like interchangeably, the same wire for both. So you got to be careful when you wire this, that if you are going to do an interrupt, that you're interrupting like low voltage. You don't want to have a control wire that has 120 volts hot going out and coming back, DC or AC. You want it to keep it down to 24 volts or below. And if I can't determine that that's what we're doing here with this stop feature, I can add a relay to this, you know, powered by the battery, and controlled by the dry contacts, you know, like 12-volt relay or something, like a Bosch relay or something, in here to control this. So my control circuit going out is isolated. And so basically, as your batteries get low, that dry contact relay, it's a switch that'll close, that'll turn your generator on. This does not have a delay on when it actually sends power to the loads. That's something else I have to add. It is on the newer schematic. They've got something here called a transfer delay relay that isn't on the old schematic. So that's something I want to add, because I do want the generator time, especially like now it's not so important, but during the winter it's going to be cold and I want to have time to warm up before it starts powering loads like a charger or something like that. So anyway, that's what I'm working on today. Leave your comments in the doobly-doo.